Good day, guys. Thank you very much for watching again. My name is Renato, and here we are just using Google again, doing a search for Cisco Binary game. And right away we can find it here. We'll click it. This is the Cisco Learning Network, and this is an amazing game. They used to have like another 7 games which were pretty cool too. They were very useful to learn other subjects from the CCNA and CCNP. This is the one that's left. For some reason they took all the rest off. I guess they were outdated already. So they left this one because this is a general concept that prevails pretty much for the years to come, because we're still using IP version 4 mainly, and we need to know how to convert all the decimal information into binary bits. So this is very fun. All we need to do is just click play the binary game. Now we'll rotate the device and play the game. So very simple, just convert like that. We can turn the sound off to 16. Very straightforward. What we're doing here is we're reading the table below and we're just doing an arithmetic sum, and we'll see who does the most. It has a timer and we're competing around the world to see who gets the highest record. There are some Indian guys. They are very good at mathematics because they use Vedic math and very nice techniques. So it's kind of hard to compete with them. I've gotten a very nice placing, but there are some Indian guys who are just crazy good. So here, for example, we're just doing 255. How many bits give 255? All ones, right? How many bits do give 2551? How many bits for number 2? Alright, that was all zeros, then a 1, and then a 0. Here, what bits would give us 5? Guessing. So here we have a number 4, then 0. We will mark 0, and we'll leave that one as a 0. If we mark it, we're saying 6. Do you agree? If we activate this one, we're saying 12. We're just summing, right? It's just simple sums. And here, that's just 131. We start doing it automatically, and this is the magic of the repetition, that the more we do it, the easier it becomes. It becomes natural. Just instinctively we can find out the answer. And whenever we're working with IP address and we're wondering, alright, the mask should have a specific number of bits, then we know. And if we have a CIDR mask, for example, and that CIDR mask is telling us, alright, this is the host numbers, and how many hosts are in this network? What's the address space that corresponds to this specific network? So on and so forth. It becomes very natural to do the calculations because we already trained a lot with this kind of training games. Alright, I wanted to share this one with you because not everyone knew it. This is amazing. Alright, here actually, if 128 is activating just this one bit that I'm toggling right now, this one is all by itself is 128. That means that if I deactivate it and leave it at 0 and activate all the rest, that's 127. Did you see? It took it right away. 32. The faster you become, the better for the test, because on the test there's a timer. You need to be able to solve the subnet masks as quick as possible, especially the subnet masks. All the bits here are 255. I'll just deactivate the number 1, so I get 254. As easy as that. Now, I'll show you another trick. We can actually pause that one. and we can go ahead and do a search here. All right. Finger subnetting. All right, this one actually, this is a weird thing because I found out, let me turn the screen back again. I just found out this trick on my own. All right, I tried to organize the bits with my hands so it became easy to understand it, easier to do it. Later on, I searched for it, and it turned out other people also came up with it. So this is a very nice technique because it makes you a lot quicker. When calculating with the fingers, it becomes very natural. Here, as we can see, this is a very easy explanation. The first finger represents number 1, number 2, number 4, number 8, number 16, number 32, number 64, number 128. All right, you're just using the 4 fingers from the top of your hands. All right, the thumbs are just holding there. You're just using 4 on the right side and 4 on the left side. Basically 8 fingers representing 8 spaces for bits. So if you close your fingers and you just leave 1 finger on up, for example number 1, what happens is binary 1. All right, and mentally you assign that number. Then if you put your 2 fingers, the rightmost fingers up, if you put your rightmost fingers up, I hope you were listening. All right, if you put your rightmost fingers up, then that means 3 in decimal. You're using 2 binary bits, so your fingers represent 2 spaces, 2 binary bits, and they represent number 2. I mean, the decimal value of 3. It makes you a lot quicker. This is a nice technique to use. First using the fingers, but then you start visualizing the fingers in your mind. This is kind of like Vedic maths in some kind of way because it resembles it. In Vedic maths, whenever you practice more and more with your fingers, you start visualizing them only when you're with your mind. And you have to reach that level because in the test, it's actually prohibited to put your fingers out and just start doing calculations because they want to avoid anyone from, seeing the answer from the hands, like physically written. There's some guys who do that, so the Cisco has become very strict in that aspect, and they want you to do everything from your knowledge, from your head, which is a nice thing. Actually, we ensure that the people who really know the subnetting actually pass the test. So yeah, that's the technique, guys. I hope you like it. That's what I used to learn 7 seconds of netting. Then I would also recommend you to look for Professor Messer's 7 seconds of netting. That's a very nice, very good, very practical technique. Whatever he uses, he's explaining it for the Network Plus certification, but it's also useful for the subnetting for the Cisco CCNA. Why? Because pretty much all the devices utilize the same bits, right? All right, then. I hope you liked it. Thank you very much. Please like, share, and subscribe, and hit the bell. Thank you.